Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss an example to further elaborate on the working of Dijkstra's-Bankes algorithm. Let us consider that in a system there are 4 resources and there are 5 processes. So, m is equals to 4 and n is equals to 5. Available M is defined as 3, 14, 12, 12, which implies there are 3 instances of resource R1, 14 instances of resource R2, 12 instances of resource R3, and 12 instances of resource R4 respectively. So available M has 3, 14, 12, 12 instances of resource R1, R2, R3, R4 respectively. Now we have 5 processes. The 5 processes are represented as process P1, P2, P3, P4 and P5. Now max NM, it represents the maximum resource requirement of the individual processes. So P1 requires 0, 0, 1, 2 instance of R1, R2, R3, R4 respectively. So that is the way how interpretation is done. So P1 requires 0, 0, 1, 2 instance of resource R1, R2, R3, R4 respectively. P2 requires 1750 instance of R1, R2, R3, R4 respectively. P3 requires 2, 3, 5, 6 instances of R1, R2, R3, R4 respectively. Likewise, P4 requires 0, 6, 5, 2 instances of resources R1, R2, R3, R4 respectively. And eventually process P5 requires 0, 6, 5, 6 instances of resource R1, R2, R3, R4 respectively. So this is the maximum requirement of the 5 processes that are there in the system, wherein the number of resources that are available are 3, 14, 12 and 12. Now initially I'm assuming that none of the resources are allocated to the processes, so allocation NM is all specified as 0. And the request and subsequently allocation, once allocation is done, what will be the status, and then eventually need, which is the difference of max and allocation, right? So now let us consider that the processes P1, P2, P3, P4 make request for the set of resources that are specified in the request. So P1 requests for 0, 1, 1, 2 instance of R1, R2, R3, R4 respectively. P2 requests for 1, 0, 0, 0 instance of R1, R2, R3, R4 respectively. P3 requests for 1, 3, 5, 4 instances of R1, R2, R3, R4 respectively. P4 requests for 0, 6, 3, 2 instances of resource R1, R2, R3, R4 respectively. Likewise, P5 makes request for 0, 0, 1, 4 instance of resource R1, R2, R3, R4 respectively from whatever is the maximum requirement of that particular process, right? Okay, so we have specified the maximum requirement. From that maximum requirement, it's making certain request. So now that request is to be allocated. Now let us consider that whatever is being allocated, whatever is being requested by the 5 processes are being allocated to the 5 processes, right? Okay, so now process P1, P2, P3, P4 and P5, they are being allocated, or they have been allocated with the required number of instances of resources, and eventually the total allocation is drawn as 2, 9, 10 and 12. So 2, 9, 10 and 12 instances of R1, R2, R3, R4 has been allocated to the processes P1, P2, P3, P4, P5 based on the request matrix. So here what we have done is we have allocated resources to the 5 processes based on the request matrix, right? Okay, and we have determined the new allocation, which is allocation plus request, and we have found that 2, 9, 10, 12 instances of resources R1, R2, R3, R4 has been allocated, and we are left with 5, 2, 1, 5, 2, 0 instance of R1, R2, R3, R4 respectively. So here, just see, out of 3, 14, 12 and 12, 2, 9, 10 and 12 has already been allocated. So we are left with 1, 5, 2, 0 instance of resource R1, R2, R3, R4 respectively. So now just see, this is the status of the system after allocation of the request is done. So now what we need to do is we need to determine the need, right? Okay, so need is equals to max minus allocation. So we have already learned about it. So need is equals to max minus allocation. So if you subtract allocation from max, what we'll get is we'll get need. Say for an example, 0012 minus 0012 will be all zeros, right? So need of process P1 now is all zeros. Likewise for process P2, 1750 minus 1000 is 0750. So now the need of process P2 is 0750, because after a certain amount of allocation, what we have done is we have determined the need. So need is maximum minus allocation. So likewise for P3, max is 2356. We have P3 has been allocated with 1354. So now the need is 1002. Likewise for P4, 0652 is the max. So 0652 minus 0632. Now the need will be 0020, right? Eventually for P5, max is 0656, allocation is 0014. Now need is 0642. So this is the way how need matrix is determined. So need matrix is determined by subtracting allocation from max. So we have 2, 9, 10, 12 instances of R1, R2, R3, R4 already being allocated, and with us we have now 1520. So now this 1520 instances of R1, R2, R3, R4 is to be wisely utilized so that the system does not enter into a state of deadlock. So we need to generate an allocation sequence in such a manner that the system does not enter into a state of deadlock. So we need to use this 1520 wisely so that appropriate process is selected, so that in order to cater to its request, eventually ensuring that the system enters into a safe state. So now this is the strategy of the Banker's algorithm. So now we'll select a process which can complete its execution with whatever resource that is available. So we have 1520 instances of resources R1, R2, R3 available with us, right? So with that, we'll try to select a process that can be catered to, and eventually the process can complete its execution. So if you analyze the need matrix, there exists a process P1 whose need is 0000. So what we can do is we can allocate 1520 to the process P1 and make it complete its execution. So once 1520 is allocated to P1, P1 will complete its execution and it will release whatever was allocated to it, right? It will release whatever was allocated to it. So now process P1 is selected. So here Y represents selection of a process that can be catered to with whatever is available, and F represents the status that the process has completed its execution. So here P1 is initially selected and it's assigned with 1520. It completes its execution, and then it releases whatever resources was allocated to it. So now the status of the available resource will be 1520 plus whatever was formed or whatever was released by process P1. So if you see, P1 was holding 0012 instance of resource. So 1520 plus 0012 will be 1532. So this is the way how the available resource is updated. So available resource will be now the sum of whatever was available and whatever is obtained after deallocation of the resources by the process that has completed its execution. So here process P1 has deallocated the resource, and that resource has been added to the available set. So it was allocated 0012 instance of resources. So 0012 was released and added to the available set. So the available set is updated to 1532. Now you need to select another process that can be catered to by 1532. So if you closely analyze, there are two processes that can be catered to by 1532 instances of R1, R2, R3, R4. These are P3 and P4. So see, P3 has a need of 1002 and P4 has a need of 0020. So either of these can be selected in order to proceed on with the execution. So here what I have done is I've selected P3. So P3 is assigned with 1532 instance of resources R1, R2, R3, R4 to enable it to complete its execution. So once process P3 completes its execution, it will release whatever was allocated to it. So it will release 1354 instance of resource R1, R2, R3, R4 that was previously allocated to it. So once it releases it, the available set will now be updated to 2886. So 2886 is formed after addition of 1532 and 1354. So 1 plus 1 is 2, 5 plus 3 is 8, 3 plus 5 is 8, and 2 plus 4 is 6. So 2886. So now P3 has completed its execution. Now we'll try to determine a process that can be catered to by 2886. So there is a process P4 that can be catered to. So we'll select that particular process, assign the resource 2886 to process P4, let process P4 complete its execution, and then eventually update the available set. So now available will be updated as 2, 14, 11 and 8, which is sum of 2886 and 0632. So 0632 was the
number of resource instances that were allocated to process P4. So 2 plus 0 is 2, 8 plus 6 is 14, 8 plus 3 is 11, and 6 plus 2 is 8. So this is the way how the available resource set is updated. Now out of the two processes that are left, P2 and P5, we need to select one. So I'm selecting P5. Okay, I'm selecting P5. So P5 will be assigned with 2, 14, 11, 8 instances of resource R1, R2, R3, R4. It will complete its execution. The resources will be deallocated and it will be added to the available set. So here available set will now be updated to 2, 14, 12 and 12. So 2, 14, 12 and 12 is formed after adding 2 with 0, 14 with 0, 11 with 1 and 8 with 4. So it will be 2, 14, 12 and 12. Now there is only one process that is left, that is P2, that can be catered to by 2, 14, 12 and 12. So here a resource 2, 14, 12 and 12 is allocated to process P2. P2 will complete its course of execution. It will then deallocate the resources, and then the available resource will be updated eventually. So now just see, the available resource is updated eventually. So the available set has 3, 14, 12 and 12 resources available, and the total allocation has all come down to 0. Now just see here, this is a safe sequence. So P1, P3, P4, P5 and P2. So if we execute the process in this sequence, the system will not enter into a deadlock state, or it will enter into a safe state. So this is the way how the banker's algorithm works. So here what we had done, we had taken 4 resource types, we had taken 5 processes, we had defined max, and then we try to allocate the requested instances of resources to the individual processes. Then we determine the need matrix, and based on need we selected the appropriate sequence of processes which can be satisfied in order to ensure that the available resource is capable of satisfying the request of the processes. And as and when process completed its execution, the available resource was updated, and the updated resource was further used in order to cater to requirement of some other process. So this is the way how the banker's algorithm works. So this is a very important algorithm in context to operating system and deadlock avoidance. So all of you need to take So what you can do is you can generate your own questions regarding Banker's algorithm, and you can try to solve it and determine whether the system enters into into a safe or unsafe state based on the allocation sequence that you have pursued. So I seriously advise all of you to take different examples of Banker's algorithm and see the way how the Banker's algorithm works. So this is what Banker's algorithm in detail. So thank you very much. Have a very nice day.